Hello everyone. Today we are going to see the part 2 of the lecture 1. Today we are going to see the brief concepts in tokens. First of all, we will see identifiers. An identifier is a name used to identify a variable, a function, a class, a module, or an object. Identifiers helps in differentiating one entity from other. Python is a case sensitive language, meaning age. Wait, let me give an example for you. First, small age means that age written in small letters. Then, when we write A with K caps and G in small, there is a lot of difference between age and this age. Let us consider another example. Let me give a variable name where COD code tantra 1. This is the first variable where I stored a value. Second, in small case, I give n, a, m, e. I store another value, that is code tantra 2. Here there is a lot of difference where you can see a variable with caps n and another variable with small n. So students, there is rules for declaring the identifiers. Okay, students, let me now explain the rules for writing an identifier. So now there are five important rules. First, identifiers can be in any combinations of lowercase, that is small a to small z, or uppercase letters, that is caps A to cap z, or digits 0 to 9, or an underscore. You can see the example. My class variable underscore 1 print underscore this underscore 2 underscore screen. Then the last example is underscore number. The second rule, an identifier can start with an alphabet or an underscore, but not with a digit. Example, 1 underscore variable is invalid identifier, where variable underscore 1 is perfectly fine for an identifier. Third, keywords can be sorry, keywords cannot be used as identifiers because they are reserved words in Python where they have a special meaning. Example, def and not for etc. Fourth, special symbols like these are the special symbols where exclamatory, alpha, dollar symbol, reminder symbol, and symbol, etc. are not allowed as identifiers. Only the priority goes to underscore. Example, hashtag name, email ID at ID are invalid. The last rule is identifiers can be at any length. Next, moving upon to naming conventions for Python identifiers. Let me explain each and every point with a neat example. Sorry, let me change the font. Okay, students. The first point, class names start with an uppercase. All other identifiers start with a lowercase, where class is written in small, student S is written in caps, and pass statement is given. The class concept will be taught in upcoming lectures, but you still remember that is class names start with uppercase, that is student here. Second point, variable and function names start with lowercase. Let me show the example in ideal Python. See, the variables and the uppercase, the variables and function names start with lowercase, that is student name, age 20, marks 95. Then definition, calculate sum, then pass. So moving to the next point, that is starting an identifier with a single leading underscore indicate that is private, where starting of identifiers with two leading underscores indicate that is strongly private. Where now I am going to give the examples in ideally Python. Class student def init. These concepts will be coming in upcoming lectures after tuples. So I will be teaching the concepts there. So don't be confusing and don't get scared. Okay? And just giving an example. So see, a single underscore before the marks tells other programmers that this variable is intended for internal use. Python does not prevent access, but it has convention to treat it as a private. The third point example is clearly given to you. Now moving to the same part in the third point. Double underscore triggers name mangling. That is, double underscore starting before an identifier is strongly private. Where, let me write. You can give any name or something. Okay. A double underscore before the password makes it harder to access the attribute directly from outside the class. It is often used to protect internal data. So, moving up to the last point, that is double underscore before and after an identifier indicates a special meaning. Example, double underscore dog, double underscore. These are special names provided by Python. They have predefined meanings, so don't they have predefined meanings, so we don't create them ourselves for ordinary variables. So let's move on to next part that is very important for upcoming lectures, for coding, etc. That is keywords. Keywords. Every programming language usually has a set of words known as keywords. These are reserved words with special meaning and purpose. They are used only for the intended purpose. Note, we cannot use a keyword for as a variable name, function name, or as any other identifier name. Python also it owns set of reserved words called keywords. The interpreter uses the keywords to recognize the structure of a program. In Python 2.0 version, we have 32 keywords, while in Python 3.5, we have 33 keywords and non-local keyword was added to it later. Note, in Python 3.5, introduced async and await as context-dependent keywords and their usage as identifiers was deprecated. Deprecated means it was just having a negligation to use. In Python 3.7, they brought async and await whereas keywords, resulting in total of keywords, while Python 3.5 has only 33 keywords. But in Python 3.17 version, we have 35 keywords. So students, now I am going to give the important 33 keywords. But most probably only we will be using 33 keywords. No need of 35 keywords. But you can just remember for your 1 mark questions or for Viva. So the 33 keywords are. Now shall I give the keywords and their uses. First, false. Represents the Boolean value false. Second, none. None represents no value or null value. True represents the Boolean value, true value, and performs logical and operation. As gives an alias name while importing modules or while handling the exceptions. Assert. Assert tests whether condition is true. Next seventh one is async. Declares an asynchronous function. Await. Waits for a asynchronous task to finish. Break. Exits the loop immediately. Class. Defines a class. Continue. Skips the current loop iteration and moves to the next iteration. Def. Def means definition, definition to a function or defines a function. Del. Deletes a variable, object or an item. Elif. Elif checks another condition if the previous condition is false. Else. Else execute code when the if condition is false. Except. Except handles errors, that is exceptions. Finally. Finally executes code whether an exception occurs or not. For. Creates a for loop. From. Imports specific object from a module. Global. Global declares a global variable inside a function. If. Executes code when a condition is true. Import. Imports a module from a library. In. Checks membership or is used in loops. Is. Checks whether two objects are the same object. Lambda. Lambda creates an anonymous function. Non-local. Non-local refers to a variable in the nearest enclosing function. Not. Performs logical not operation. Or performs logical or operation. Pass. Acts as a placeholder or we can say it just do nothing. Next. Raises an exception manually. Then 31. Return. Returns a value from a function. Then try. Starts exception handling. Next while. Creates a while loop. With simplifies resource management and working with files. Yield returns a value from a generator without ending the function. So students, keep remembering the keywords until unless you get the keywords in the correct way to use. Is evolution of Python keywords are still going on? Yeah, all the keywords from earlier Python versions are still valid and can be used in the latest versions. In addition, some new words were introduced in recent updates and new versions. Let's explore some of them. First, the first word is non-local. Non-local. It was introduced in Python 3.0, used to modify a variable in the nearest enclosing scope. Not global scope, can be used in local scope. So let me move to the ideally Python to give a program. One second. Def outer x equal to outer def inner x is equal to changed sorry changed in inner. Let we can call the function inner. Then we can give print x. Now we can save it as pro.py. Now we can give the fi module. We have to give the outer in the outer definition function. Now when we run it, sorry, we have to give small x. Once again, when we give without non-local keyword, it prints outer. Everyone can see the output as outer. But when we give a non-local keyword before this variable x is equal to changed in inner. When we give non-local, it is a keyword. Non-local x. Now, when we run it, When we use non-local keyword with the variable x, the output changes. This is the use of non-local. Without non-local, assigning to x in inner would create a new local variable instead of modifying the outer variable x. Second, async and await. Introduced in Python 3.5 version but formalized as keywords in 3.7 Python version. Used for asynchronous programming to write non-blocking code. Async defines a coroutine and await pause execution until the awaited task completes. It is introduced in Python 3.5 version and became reserved words in Python 3.7. Next, moving to match and case. Introduced for structural pattern matching, similar to switch case in other languages, but more powerful due to support for complex data patterns. You will learn about match case in detail in further upcoming lectures. Fourth, type. Introduced as a keyword for advanced type hinting. It helps define generic types in annotations. That's all for the keywords topic. Move to the third part of the tokens, that is variables. In Python, a variable is a reserved memory location used to store values. In Python, being a dynamically typed language, there is no need to declare variables or declare their types before using them. Python has no command for declaring a variable. A variable is created the moment a value is assigned to it. The equal to operator is used to assign the value to a variable. Note, operators are special symbols used in programming languages that represent particular action. Equal to is called the assignment operator. For example, for example, let me show variable variables. Marks is equal to 100. Here, marks is a variable and 100 is a value. Okay, students? Wait, let me make the size bigger. See, marks is equal to 100, where marks is a variable, 100 is a value. Python interpreter automatically determines the type of data based on the data assigned to it. In Python, we can even change the type of variable after it has been set once. This can be done by assigning a value of a different type to the variable. A variable in Python can hold any type of data like integer, float, string, etc. We will be learning more about data types in the upcoming lectures. As a good programmers, we should give meaningful names to variables. Then, another note that is, at any given point of time, a variable can hold only one value. You can't assign multiple value at the same time. Associating a value with a variable using the assignment operator is called as binding. In Python, when you assign a value to a variable, you're actually creating a reference to that value, not making a copy. Python uses reference semantics, which means that variable essentially point to objects rather than containing the objects themselves. We cannot use Python variables without assigning any value. If we try to use a variable without assigning any value, then the Python interpreter shows an error saying name is not found. So now let me give a practice question. Also, I will be doing with you. So open ideally Python where A is equal to B is equal to C is equal to hello. Print once again. Print A, print B, print C. So now we can save the file. Then when we do F5, we get hello, hello, hello. But we can also give a different variables to it. That is A is equal to 99. B is equal to hello. C is equal to 31.5. When we give F5, sorry, print A, print B, print C. Now let's see the output for this code. F5, C, 99, hello, 31.5. So next, assignment of variables. Python variables do not need explicit declaration to reserve memory space. The declaration happens automatically when you assign a value to a variable. The operand to the left of the operator is the name of the variable, and the operand to the right side of the operator is the value stored in the variable. Now, let us see an example program. The program is to change kilometers to miles. Okay. kilo is equal to int input enter a value. Convert factor, that is, this factor has a particular value, that is 0.627 sorry 1371. Then miles is equal to kilo multiplied by the convert factor. Convert factor. Now print miles. Let us save the file. F5. Enter a value, that is 10 kilometer. 6.21371. Enter. We got the result. Let me give 100. 62.13710000. It goes on and 4. So students, next moving on to the next topic, that is fourth part of tokens, that is operators. What is operators? Do anyone know? Uh, Let me define. An operator is a special symbol that performs an operation on one or more values called operands. So now let me show. A is equal to 10. B is equal to 20. Now A plus B is equal to 30. So here, wait once again. The A is variable, 10 is value, B is a variable, 20 is a value, where these two are operands for the third statement, where the A variable is added to B variable, then the results give as 30. So the operator performs addition and the result is being 30. Let us see the types of operators. First, arithmetic operators. Second, comparison operators. Third, assignment operators. Fourth, logical operators. Fifth, bitwise operators. Sixth, membership operators. Seventh, identity operators. Let go with the arithmetic operators. Python supports 7 arithmetic operators, that is addition, subtraction, multiplication, division, exponential, remainder, and floor division. So let's see a program. You will get a better idea. See, program is to perform arithmetic operations on two numbers. Let's take num1 is equal to int sorry int input num1 num2 is equal to int input num2 add is equal to num1 plus num2 sub is equal to num1 minus num2 mul is equal to num1 multiplication num2 div is equal to num1 division num2 x is equal to num1 double star num2 rem is equal to num1 modulus num2. The last and final operator, that is floor division, is equal to num1 double slash num2. So now we can give the repeating statements. Print, add. Wait a second. Now F, you can give F5 key. Num1 can be 6. Num2 can be 5. When we add 5 and 6, we get 11. When we subtract from 5 from 6, we get 1. When we multiply 6 and 5, we get 30. When we divide 6 by 5, we get 1.2. When we give the 5 to the power of 6, that is 6 to the power 5, the answer is 7776. When we perform remainder operator, we get 1. When we perform floor division operator, also we get 1. So let me display the outputs. Once again, see, the outputs are here. So next, moving on to the next operator, comparison operator. Comparison operator gives the result either true or false when it is operated with two operands. We have basically 6 comparison operators. Let me show an example. Let's take num1, program to check the relationship operator. Num1 is equal to int of input of enter num1, num2 int of input of enter num2. Now directly we can give the print statements. Print num1 is greater than num2. Print num1 is less than num2. Print num1 double equal to num2. Print num1 not equal to num2. Print num1 is greater than or equal to num2. Print num1 is less than or equal to num2. Yeah, now we can save the file. Bitwise operator. There are only 6 bitwise operators, that are left shift, right shift, logical and, logical or, logical not, logical XOR. Let me give a example program with every bitwise operator. Program to see the operation of bitwise symbols. Now, let's take two inputs, x int of input of x, y is equal to int of input of y. Print. See, the bitwise operators has given the results. So students, practice more in bitwise operators because you will get more tough questions from bitwise operators. So next, moving to the next operator, assignment operators. Assignment operators are used to assign values to a variable. There are, so okay, let me give an example. A is equal to 52 or 50. Here it is a simple assignment operator that assigns 50 to the variable A. So right hand side is the value, left hand side is the variable. Note, an assignment operator assigns the value located on the right hand side of the operator to the variable located on the left side. The right side of the operator can be operated or an expression that results in a value. The left hand side should be a variable. So next, let us see the types of assignment operators. First, assignment operator that is equal to. Second, add and assign. Third is subtract and assign. Fourth is multiple and assign. Fifth, divide and assign. Sixth is floor divide and assign. Seventh is modulus and assign. Eighth is exponent and assign. Ninth is bitwise and assign. 10th is bitwise or and assign. 11th bitwise XOR and assign. 12th right shift and assign. 13th is left shift and assign. Now let me show a example where you can cover all the assignment operators. Let me go to the ideally Python. Let us assign a is equal to 10. Then print, sorry, a plus equal to 5. Print a. Next, a minus equal to 3. Print a. A multiplied equal to multiplied by 3. Print a. Next, a divided equal to 3. Print a. Next, a floor, floor division 3. Floor division equal to 3. Print a. A modulus equal to 3. Print a. Then a exponent equal to 3. Then print a. Then a logical and equal to 3. Print a. Now bitwise OR operator. A bitwise OR operator equal to, that is assign 3. Then print a. Then a bitwise XOR operator and assign 3. Print a. Then a greater than equal to 1. Sorry, right shift as and assign 1. Print a. Then a left shift assign 1. Print a. Now let us run the code. Students, now we can see the result, that is F5. Once again, let me show the result. See students, the output of the types of assignment operator what we have given in the code, it has been executed and the output has been produced. So moving to the next part, logical operator. Logical operators are used primarily in the expression evaluation to make a decision. They allow you to create complex conditions and control the flow of your program using conditional statements like if else, if else, etc. So now we can go to the logical operators. There are only three logical operators, that is logical and logical logical or and logical not. First, logical and returns true only if both conditions are true. If for any one condition is false, the result is false. Syntax, that is condition 1 and condition 2. If a is equal to 10, let's see here, that is a is equal to 10, then print a greater than 5 and a less than 20. So it gives true. Second, logical OR. It returns true if at least one condition is true. Return false only when both conditions are false. Syntax is condition 1 or condition 2. Example. Let's take a is equal to 10. Then print a is greater than 5 or a greater than 20. Here, both conditions are satisfied, so it gives the result as true. Third one, logical not. Logical not reverses the result of a condition. If the condition is true, it returns false. If the condition is false, it returns true. Syntax, not condition, that is complement to the condition. Example, a is equal to 10. Print not a is greater than 5, where a is greater than 5 is true, but we have given a keyword that is not. So it gives the complement result that is false. So moving upon to the next, that is membership operator. What is membership operator? The operators in Python are used to test the presence of an operator in a string, list, tuple, etc. The result of this operator is Boolean value, either true or false. First of all, in membership operator, first is in. It returns true if the specified value is present in a string, a list, a tuple, or a set. It returns false if the value is not present. Syntax, value in sequence. Then example, the list fruits is given where the list contains apple, banana, mango. Print apple in fruits where the list contains the apple string. So the result is true. Second, not in. True, it returns true if the specific value is not present in a sequence. It returns false if the value is present. Value, its syntax is value not in sequence, where same. Fruit is a list where the list items are apple, banana, mango, where the print statement gives that orange not in fruits. Yes, the list does not contain orange item. So it gives the result as true. 7. The last operator, that is identity operator. The identity operator checks whether two variables refer to the same object in a memory. Let's see the identity operator. First one is. Is returns true if the both variables refer to the same object material in the memory. It returns false if they refer to different objects, even if the values are equal. Syntax. Object 1 is object 2. Example. A. A has a list carries 1 and 2. B is equal to A, where we are assigning A to a new variable that is B. So print A is B. So here the both lists are same. So it gives true. Where second is not. It returns true if the two variables refer to different objects in a memory. Returns false if they refer to the same object. Syntax. Object 1 is not object 2. Example, A is a list where it has 1, 2. B is a list where 1, comma 2 is also present. So here the both variables holds the same type of list and also the length is same, the object is same. So now the print statement is giving a false allegation, that is A is not B. So yeah, it is not the same but stored in different objects. Sorry, different variables. So it is stored in different memories. So A is not B, it's just a copy of A. So the result is true. The last and the final topic in tokens, that is punctuators or delimiters. Delimiters are the special symbols used to separate, group, and organize different parts of a Python program. Common delimiters in Python. First one is parenthesis. Parenthesis used for function calls and grouping expressions. Example, print hello Python. Result is equal to 10 plus 5 into 2. Second, that is square bracket, used to create list and access list elements. Example, fruits is equal to apple, mango, orange. Print fruits, where the result will be like apple, mango, orange. Curly braces. Curly braces used to create dictionary and sets. Dictionary example, student is equal to name Ashwin, age 20. Always the dictionary will be in the form of key pair values. Print student. So the dictionary will be displayed from name Ashwin, age 20. Set example. Colors is equal to red, blue, green. Print colors. The whole set will be displayed. Fourth, colon. It is used to start a block of code after if, else, for, while, def, class, etc. Example. If age is equal to 18, it has been assigned. If age is equal greater than or equal to 18, print eligible to vote. Next, moving to comma. It separates multiple values or variables. Example, a comma b comma c is equal to 10 comma 20 comma 30, where here a is assigned to the 10, b is assigned to the value 20, c is assigned to the value 30. Now print a comma b comma c. So in the same line 10, 20, 30 will be displayed. Sixth, dot. Dot is used to access methods and attributes of object. Example, name is equal to Python. Print name.upper. Name.upper means the Python string will be converted into uppercase, that is caps P, caps Y, caps T, caps H, caps O, caps N. Seventh one is semicolon. It separates multiple statements on the same line. A is equal to 10, semicolon, B is equal to 20, where assigning in different lines may take time. So the programmers may use this method to assign quickly and get the output quickly. So A plus B is equal to 30. Eighth one, single quotes and double quotes, used to create string values. Example, print hello, print Python. Ninth one, equal sign, assigns a value to a variable. So, example, here Ashwin is a string is assigned to a variable name. 20 is a age, that is int data type is assigned to the variable age. At symbol, use for decorators. Example, at static method. It is used as a decorators here. Then def display, the function has been given. Then print hello. So students, before moving to the next lecture, I have a few questions to practice. Pause the video, think about the answers, and then try them on your own and comment in the comment box. So the first question, that is, What is a keyword? Then, can we use a keyword as a variable name and why? Name 7 types of operators in Python. What is the difference between arithmetic operators and comparison operators? Next, what are delimiters? Then, name any 5 delimiters used in Python. Then, what is the purpose of colon in Python? Then, explain the use of bitwise operators. Then, explain the use of parentheses and square brackets. So, moving on to some coding questions. Write a Python program to print your name, school, department, that is section. Then second program is write a program to perform addition, subtraction, multiplication, division among any two numbers. That's all for the practice question. So totally you have 9 theory questions and 2 coding questions. Give me the theoretical question answers in the comment box and try the coding questions in your own. In the next lecture, we will be moving one step further to learn what is data types, input and outputs, type conversion, then Python control statements including if else, if, elif and nested loops. Thank you so much for watching lecture 1 part 2 of our Python full course. I hope you now have a clear idea of tokens, that is identifiers, variables, keywords, operators, and punctuators. So, if you found this lecture helpful, please like the video, share it with your friends, and subscribe to the channel so you don't miss the upcoming lectures. Until then, keep practicing, keep learning, and remembering consistency is the key to the success, and every beginner is a great programmer in the future. Thank you. I will see you in the next lecture. Happy coding!